Okay, we're recording. We're going live. So, John, Christian, and Mark, which group are you in? I need one from every group. 5 and 3. 1 and 2 not here, man. How are we going to do this? Let's wait a few more minutes, okay? Any questions? You can type your questions here, and we take care of your questions right now. You're supposed to input data long time ago if you know how to do it. If not, then today I already explained how to input data, right? You don't input data during the session. You just set up the parameters and input the data with your groups and then do analysis. So any questions, Christian? You put on your mic, Christian. So the questions?
Yes, I just wanted to confirm the process for inputting the data since it's a group project, right? But individually, we all have different sets. We could share the data with each other, but that means that we're only working on one file at a time, essentially, during SPSS.
Yeah, so what you can do is, you guys can put it in an Excel spreadsheet, Google Excel or something, and then later on cut and paste it in. But you better make sure you and your groups coordinate how to enter the data.
Okay.
You know what I mean? You're not
Yes.
you're supposed to have like, 10 data on one SPSS database and they have another 10 on another one, and then you have 4 databases. No. We need a consolidated base.
Right. Yeah. Just one. Yeah. That's what I just wanted to make sure.
Okay. All right. Today, I really need people from all groups here, only 3 and 5. Then I got to repeat 1 and 2 again later. Uh, let's see. Have you guys even set up the variables for the data sheet? Anyone? Okay, so John's question, grades on week 1 and 2 discussion. What grades you want, man? Quizzes and participation is only 10 points. And then the project is 50 points. So 50, 40, and 10. No, 40, 50, and 10. 50 for quizzes, 40 for project, 10 for participation. Okay, so 1 point. Very good. Yay. For your week 1, and then week 2, another point. Yay. So it's the quizzes that matters. Okay, quizzes and stuff. All right, so hold on. Let me wait 1 or 2 more. Set up the, open up the database first if you have any, okay? Only 3 people. Only Christian, John, and Mark still. Not so good. Okay, all right. So nobody's going to be here today. Okay, so open up your SPSS, and then we're going to go SPSS. I'm going to share my screen, and then we're going to go from there. Okay, group 5 and 3 only today. All right, share the screen. Ready? And go. Share the screen desktop. Okay. All right, can you see my screen? Where's the chat screen? Okay. Then where's the chat? Chat room, chat room. Chat, okay. All right, John, you can see it. Mark, no. If you can see my screen, the SPSS screen, type yes. Okay, so last week we talked about entering the variable view, right? The variable view here, variable view. Okay, so you have data like 1, 2, 3 all the way to x50. So y11, 1, 2, 1, 3, and then you have 1, 1, 1, 2, 1, 3, then 2, 1, 2, 2, 2, 3 all the way to x53. And after x53, you have x6 all the way to x50 or x60 or 70, right? Mark, John, and Christian? Agree so far? Okay, good. And then we talk about ordinal and nominal here. So ordinal is for the Likert scales, like here, ordinals, all right? And then nominals are for dummy scales, right? Which is your answers to your multiple choice. That's what we talked about last time. All right, are we clear here? Yes, yes, no? Okay, good. All right, so today I will start off with what we're going to do today is basically 3 things. Data entry, transform Likert questions to average, and then do an MLS regression and read the output. And that's why everybody needs to be here. Charlie and Delta, MLS regression and Delta, that's the most important part. And nobody wants to be here on a Sunday. Hey, so you see the problem we have? This is the most important Zoom, and no one's here. Okay, so, and then I already shut off the quizzes, so a few students didn't even take the quizzes. They're looking for an F. All right, so it's Father's Day. Well, I didn't know that. I'm not even in the United States. Okay, so it's already Monday morning in Asia. So, okay, all right, so happy Father's Day. I'm in Taiwan right now. Heading to Korea Tuesday. Yeah, it's fun in Asia. It's summer holiday, you know. Asia, everyone parties and play, right? Okay, so let's see. Data entry. All right, so we're going to do data transformation right now. So imagine that this is your variables view, okay? Variable view screen, this one here, 1 to whatever, and then you have entered your data, okay? You've entered your data, your 5, 6, 7, or whatever. Okay, so we're going to start off with data entry. So you're going to enter data like, 6, 6, 7, or 5, 2, 5, 4, and dummy variables is like 0, 0, 1, or something like that, okay? All right. Okay, so after you have entered your data and then you have done the stuff, you have about 50 rows, right? 50 rows, because there's only 4. You have 50 rows all the way down, 50 rows because you have 50 data sets, and you have about, I don't know, about 50 to 60 variables to enter data or something, right? Or 60 or 70. So you're going left and right, about 60, 70, up and down about 50 rows, okay? So now, what we have here, like y1, y2, y3, these are Likert scales, right? x11, x12, and x13, these are Likert scales, all right? And then x6, dummy variable, x7, dummy variable, x50 is dummy variable, okay? So what we're going to do is we need to transform the 3 y's into a y average. So how to transform to a y average? What we do is go to the variable view again, and then we create a new variable. It's called y average, okay? And then it's obviously going to be an ordinal. Then you have an x1 average, okay? And then it's going to be an ordinal. And then you're going to have an x2, an x3, and x4, and x5 average. Obviously, you got to label your y average with the name behind, all right? Like, for example, y average is for price, okay? And then maybe x1 average is for, I don't know, satisfaction or something, whatever you had in your survey, okay? So let's say then go to data view. The first thing we need to do is transform. As you can see, it's all blank here, blank, 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 right? You need to transform data. So let's transform data, compute variable, okay? So target variable is y average price. I think we're going to type it in. Y average underscore PRICE equal to numeric expression, which is open up a bracket. So it's y11 plus y12 plus y13 all right, and then everything else divide by 3. That's your average. And okay. All right, so yeah, I think so. As you can see, the column here is populated, all right? The yellow column is now populated. It used to be blank. Okay, so now let's do the other one again. Transform for the x1s. So transform, compute variable, we'll type it in again. x1 avg underscore sat. And then we clear up this. Open the bracket. x11 plus x12 plus x13, and then underscore 3. Okay. Okay. No. So we have transformed it. So you'll be doing this transformation 5 times. Are we clear? Okay. So you have 6 times, actually 6 times. Y, x1, x2, x3, x4, and x5. Okay. All right. Now, anyone got data set ready for me to demo to you? Somebody's mic is on. see who's on. Okay, we have Jenny and we have Amy. Jenny and Amy, which groups are you in? Jenny, Amy. Oh man, another group 5. Group 6? Group 5. So all the group 5s are here. All 5s are here. Wow. Nobody from 1 and 2 again. Group 5, you're on the ball, man. Full strength. Okay, so only group 5s and 3. And John, you're the Lone Ranger, I think. Okay, so basically we're doing variables input on the variable view here. Okay, and then we do transformation of data. So we transform y's and the x1 so far. So if you have a full database, you should have about 6 of these transformation: y, x1, x2, x3, xy, x5, and a lot of dummy variables. Dummy variables are your x6 all the way to your xn or x50. Okay, these are your dummies. All right, and this is your transform data. All right. Okay, so we're going to run regression after this and basically read the regression output, be able to read it in English. Okay. All right, so group 5 and group 3, do you have any database ready for demo? Yes? No? Nope. Okay. So you guys basically remember, collect your data, serialize the questionnaire. Serialize the questionnaire. Okay, every questionnaire has a number. Like this is like number 1, number 2, questionnaire number 2, questionnaire number 3, questionnaire number 4. Figure out how you're going to enter your data. Maybe Google Docs, Excel, enter it in Excel with as a group first, and then later on copy and paste, and then relabel the variable view. Okay, make sure you do the ordinals and the nominals and all that kind of stuff. All right, then you do data transformation, which is what I did just now. Data transformation. Okay, the yellow part. All right, that's data transformation. Okay, let's say you have done data transformation, you have done the data entry, everything is good. So what do we do now? Let's do what we are here for, multiple linear regression. So you're going to do analyze, regression, linear. Okay, and then the dependent variable would be y average. And the independent variables would be your this 4 here. Okay, you're going to use the stepwise, and then you're going to run. Okay, we have output. All right, we have all this stuff here. So how are we going to read this? So the first thing I'm going to read is, okay, the R square, which is I think the R is 0.985 or 0.97, which explains that 97 or 98% of the variances is explained by your model. So it's very good model. And then we have a variable here. So because I don't have a good data set, this is my output. This is what I get, okay, which is not very good. It's not a good example to show you. So what we have here is simply an equation that looks like this. Y equal to 4.333. Okay. Put the limit here and stuff. Will be, okay. No all. All right. Okay, so 4.33 plus 1.778 x50. Okay. Do you guys agree with my equation first? Yes or no? Do you understand how I got my equation? Okay. So the 4.33 came from here. 0.002 significant, 0.15 is significant at the 95 percentile, okay, not at the 99 percentile, but that's fine. So y equals to this plus 1.7 x 50, all right? So what this means in English is, all right, when all things being equal, okay, that means x50 is 0, x50 is 0, all right? So y increases by 4.333/7, which is about, I don't know, how much is that? 14%, 14 plus 40, 52, 56%, about 60%, okay? On a Likert scale, all right? Now, if we want to talk about how x50 impacts y, x50 is dummy variable. So for every, let's say, male, okay, y increases by 1.778 divided by 7, which is equal to about 20%. Okay, it could be your price or satisfaction, all right, whatever. Okay, so do you have any questions about the x50 part? I need a yes or a no. Okay, so the equation is obtained from this chart here, right? This chart, because it's significant. The rest is excluded, so you don't want to read excluded stuff. You want to do this based on the stepwise, so you only have two, all right? 4.33 and 1.778 in this example that I have here. And so I wrote this equation. So baseline is when all things being equal, x50 is 0, so y is only equals to this. So y increases by 4.333 divided by 7 because y is on a Likert scale. Because y is on a Likert scale. And so y is on a Likert scale, and so basically that's what we have, 60%. Now x50 is dummy variable. Okay, so so when we have a statement for x50, for every y increases by 1.778 divided by 7 equals about 20%. Okay. So for every male, y increases by 1.778, 20%. So now let's say if the, okay, let's stop here first. Do you have any questions until here? Okay, so let's say if you run your regression, and then in the screen here where you have the coefficients, you have constant, you have x50, and then maybe your x1 average is significant. Just say for example, okay, hypothetically speaking. So if your equation is y equals to 4.333 plus, let's say your x1 is significant. In this case, because it's a very lousy example, because I only have 4 entries, it was just to illustrate data entry. But let's say if you have something important like x1 average, let's say it's like 2.011 example, all right? It's not in the screen. X1 average and plus 1.778 x50, right? For example, right? So how do we talk about Likert scales on Likert scales? That means x1 average. So because x1 average is a Likert scale, so you got to say for every increase in X1 average, or you can talk about it in English, let's say satisfaction, all right? And then Y increases by every increase in X1 average, which is basically 1 upon 7 equal to 40%. Okay, Y increases by 2.011/7, which is about 22% maybe in price. Okay, so do you agree or understand the statement that I made if it's a Likert scale instead of a dummy variable? Yes or no? Christian, yes. Mark, yes. Jen, yes. Ruby, yes. Amy, yes. John? Okay, good. All right, so basically that's all we need to do today. So you have data entry. Make sure you enter your 2000 data points. Be able to transform Likert questions. Okay. Do MLS regression and then read the output and then write it in English. So when you write your report, you have the hypothesis, H naught and H1 on X50, and then you have the H naught and H1 on X1 average. Okay. So then after that, you say they are significant, and then to the how many percentile by reading this, the significant part here. Okay, the significant 0.02, 0.15, the significant part here, it tells you your hypothesis at how many percentile. And then you can do predictive analysis. These are called predictive analysis when you read the equation. Okay, and then this is the predictive analysis. So you must be able to write your equation, discuss the predictive analysis here, and then the baseline. All right, these three statements. Okay, so any questions for today? Basically, pretty much that's it. Since I have no sample data set from anyone.
I have a quick question.
Okay, go ahead.
So are we going to have then, what is that, 6 or 7 no hypothesis statements, X1 average, X2 average, Y1 average,
No,
X3?
only if it's significant. You see, when you run your regression, you'll have a table that looks like this, coefficients, right? Can you see my screen, everyone? The
Yes.
coefficient screen? Okay. And then you have an excluded variable screen, right? So in other words, the computer will tell you what is important, what's not. So in the coefficient screen that's important, you look under beta, which is your B here, all right? And then you write the equation based on this. In this example, which is only a 4-row entry example, because you only have 4 lines of data, all right? So what we had here was what do you call it's only one variable, the X50. But when you have like 50 rows and like 50 variables, I think this coefficient table is going to go to about 8 to 9 important stuff. All right. And then you're going to write your equation, you know, the equation like this. So for every equation that you write like that, and then when there's a variable like a dummy or a Likert variable in there, you have to write a hypothesis like this. Okay. And then you write a predictive statement on every variable that you see in which is significant. The things that are in blue are like predictive statements, all right? So there are only 2 types of statements, right? A dummy statement like this, which is, you know, only one side has only one part has the 20% thing, and a predictive one with this 2 Likert, then you have to talk about the 14% increases by how many percent, like 22%. So being able to read it is important. Understanding why there's a 7 here is important because your Likert scales are all 7s. And then writing a statement that's based on a dummy versus on a Likert is different. It's important. And then you'll be able to have a predictive conclusion. And that's what you'll recommend to clients. And you know, you guys are consultants, right? So that's what's called predictive analysis, and that's what makes money, that statement. Okay? And then you do conclusions like, so because of this, you got to increase the price or decrease the price or whatever. All right, any questions?
Thank you.
Straightforward, right? It's a lot of labor, but once you have the gist of it, it's, it just, the computer does it in like 5 seconds. All right. So all this work is for 5 seconds of computer work, and then you can read it and then, present it, write a report, and do a PowerPoint with speaker notes. Okay. So pretty much that's a deliverable in about 2 weeks' time. Other than that, pretty much that's it for the course. The rest is all data entry, labor work, and that's what you do when you're in PhD program. You do this for 4 years, keep entering data, checking, redo, change questionnaire, repeat, and then until you get a conclusion that everybody likes, and then you graduate. Okay? Simple. Got it? Okay. All right, this is research 100. So this is not like, the complex type. The complex type, there's more to it, like computer algorithms, simulations, questionnaires, multiple questionnaires. You see, like in this case, when we do this MKT 460, right? When you guys came out with a variable like an X1 or X2 or X3, you just pluck it out from the sky, right? Or something, say, hey, X1 is a variable that may affect Y. But when you're actually doing research, you have to do a lot of literature review to justify an X1. And then after that, okay, now after that you got to do more reviews and prior research papers to justify an X2, an X3, an X4, and X5. You got to explain everything, like why you put the X1 there. Because, so and so did this like 20 years ago, and they did this in Europe, therefore this is a variable that could affect my Y. And you got to justify why you put Y as the dependent variable. Why are you so interested in studying Y, right? So you have to do some literature review and justify it, and then dummy variables as well, right? You say maybe gender affects Y. So a lot of work in research is based on justifying why you set up the questionnaire. And then you got to explain and defend everything. And then everybody will debate with you and argue with you. And then once the equation is more or less justifiable, then you go out and collect empirical data, which is what you're doing right now. That's the easy part. The labor part is easy. Employ a TA or RA to do it. And then after that, you run the equation, come out with a report, and then pretty much you have a thesis, or you're doing consulting work. Okay, so the research is basically, the huge part of it is in the literature review and justification, and then after that, the empirical data collection, which is what you're doing. So then you can do this for behavioral research, you can do this for quantitative research, you can do this for theoretical research, which is basically you read about 1,000 papers and you conclude, okay? All right, that means you don't collect data, that's theoretical. This one is more empirical with a questionnaire, but you didn't justify why you do X1, X2, X3. So it's basically a very simple labor part, right? But the hard part is justifying real research, but that's not the what we're doing here. We're just understanding how research is done. To do real research, you need to do master or a PhD program. And then after that, your pay will be 6 digits and above, okay? Guaranteed. Because there's not enough PhDs out there, more jobs than graduates. So you get a job. And then after that, you can do consulting. So your income is basically 6 digits for the rest of your life. All right. If you do more, it becomes 6 digits. We were starting with 2 or starting with 3. So within 3 years, every 4 years, you're a millionaire. All right. We have a lot of millionaires in the faculty. I can tell you that. You guys don't know only. Right. Okay. So just think about it. If you're interested in research, focus on getting this, and then move on to graduate school. All right, and then apply this. And if you want to earn more money, I think you should go to Asia. Asia, if you do consulting like McKinsey, Arthur Andersen, I think that one's gone already. McKinsey. All right, and then you can do the Boston Consulting Group, BCG, and all this in like countries like Shanghai, China, Shanghai, Taiwan, Hong Kong, Korea, and maybe Singapore. Your pay is like, wow, 150 easy. All right, but it's doing consulting. That's based on research. So bachelor's degree get you 30 to 60, small money after tax. If you're okay with that, move on. If not, then graduate school or start your own small business. All right. So research is basically, this is the whole concept. All right. There are different types of research available. So, but if you like numbers, you like the reading stuff, writing stuff, and then your work is basically computer work, or collecting data surveys, then, you have a very big, bright future ahead if you do the research field. And it's more like, you will be very busy, but you have a lot of income. So basically your spouse enjoy your life, not you also, okay? So, but you'll be well compensated for this, because after like week 1, this is week 4, right? So week 1, when I told you about all this kind of stuff, SPSS, all of you were like, what are you talking about, man? Or this research stuff. Now I look through it, it's not really that difficult. But recall in week 1, day 1, when you were first exposed to SPSS and all that. That is the reaction that your clients, whether they're in companies, restaurants, will look at you and say, wow, this guy's an expert. But you're in week 4 right now when you look at this. Is it really that difficult? Right? It's just like learning a language, right? How to read this predictive stuff in blue, right? This thing here. Well, your clients have no idea how you get that from. They have no idea how to read coefficients. They have no idea what's SIG and the beta here, what it means, right? Explanation of variance via the R square here, all that kind of stuff. We do not understand that, right? As research practitioners, you just have to apply the output that's like driving a car, right? You just put the D and you can drive the car. You don't have to explain how the gear works. You don't have to explain how the engine of the car works. You just drive the car. Okay, and your clients are like the passengers in the car. They just relax for the ride. Okay, people that design the engine, those are the professors or the statisticians that design the software, that talk about the mathematical models. Those are high-level, professors or researchers that do that. I don't even do that. What for, right? I'm more interested in making them the money, right? The rest are going for Nobel Prize. All right, well, that's the different type of professor. Okay. The type is MIT, Stanford, they want Nobel Prize on that. Go ahead, Nobel Prize only $1 million. You work your whole life, only $1 million. So not much of a return anyway, but a lot of name. So for the rest of your life, people know your rest of the eternity, people know your name, okay? So it depends on your utility function and what satisfies the person. Okay, so think about it. That's research on the bigger picture. Smaller picture today, what we're doing is data entry, transform data, MLS regression, with the output, write the report. All right, that's pretty much it. Any questions? If not, then you're free to go. The rest, email me. Cool, any questions? All right, goodbye, Ruby. All right, goodbye, John and Christian. Okay, take care. All right, take care, Mark. Bye, Amy. I'm going to record this and then we're going to put it on YouTube. All right, cool. All right, so do your work and then we see the assignments still on next Sunday, okay? Not this coming Sunday. So we have 14 days to get it all done. All right, it's all due next Sunday, 11:59 p.m. Pacific time. All right, take care. Goodbye.